How's it going? And welcome back to Building a Deep Learning Framework. Today we are going to put everything together and generalize our current workflow so that when we're able to wrangle different experiments and handle switching from one task to the other without having to change a lot of our base code and only have to change a few different parameters within some sort of configuration file and continue to iterate from there. So let's get right into it. So last time we finished coding up the train functionality of the workflow, but like I had said, it's still pretty task specific. So today we're going to go ahead and fix that. So if we go ahead and look at this get dataset function, we have to pass all of these different parameters. So we're going to go ahead and change that. The basic idea of this whole workflow is we want to have just one config file that we pass to all of our functions, and then it pulls the different parameters from the config file. And basically we push this code to the back side of things, put it in the back end. We don't have to mess with it anymore. We only end up messing with our JSON file. So, all right, so now we're going to go ahead and rewrite some of these functions. So I'm actually going to go ahead and I'll copy and paste what we have here, and then I will just paste it below, and then we'll just kind of adjust what we need to adjust. So I'll code this up and then I'll kind of explain. Okay, so for this first one, we're going to get the same thing, right? We want our train samples and our train targets, and then our validation samples and our validation targets. But instead of passing the function ourselves, what we're going to do is we're actually going to pass the function in a string to our JSON file, and then we're going to read it in here, and then evaluate it, and then it'll run it on our config. And then we're also going to pass train equals true. And then we'll get into kind of this breakdown towards the end once we go and we kind of adjust the different data functions and the different model functions. But for that one's finished. So we can go ahead and move on to the next part of it. So again, here we're going to go ahead and adjust our train data sets and our valid data set functions. So again, now we're instead of, again, hand coding things, we're going to go ahead and call our dataset function from our config file. So a good thing to remember is that any type of function we're calling in here, then we actually have to define within the config file. So you can really call these anything you want. These are just things that I kind of opted for, the names that I opted for, but that's just kind of the general idea. And then here we're going to go ahead and change these to config batch. So in our config file, we will write what we want for our batch size. And that should be everything. Okay, so moving on to our getting our compiled model. Again, the thing we're going to want to change here is we're going to pass just our config. So one of the kind of workaround I've done for this is I have actually just kind of hard coded in a couple optimizers. So I've used for the base functionality for this this workflow, I've just hard coded in the RMS prop and then the atom optimizers, calling from the tf.keras.optimizers. So you can follow this same exact configuration, the same setup, and go on to Keras Optimizers website and code in any optimizer you want to use. I just, for ease of use here, I just use kind of the two most common. That way I can pass the learning rate to them, and that I don't have to necessarily write all of this out in the config file. I can just pass the name of it to the config file, and it'll automatically on the back end do this for me. So next thing we're going to want to do is if we want to restore a model and continue training on it instead of just training a model from scratch, we're going to build that functionality into it. So instead of compiling the model, we're just going to evaluate the model as is, and then print the model summary, and then return the model. That will allow us to restore one. If we're not restoring, then we're going to go ahead and compile a new model and return it. So very similar syntax. The only difference here is we are actually going to then compile it before we return it. And we are going to pass the optimizer, the loss function, which is defined in the config file, and then the metrics, which is also defined in the config file. Okay, so then we're going to go ahead and move on to the run training, right? So we've kind of updated this. So basically the things now we need to add into our config file is our load function, our dataset function, our batch size, our optimizer we want to use, our learning rate, if we're going to restore. So most of the time that'll just be false. The model we're going to use, which so a good example on how to write that right would be, so before we wrote the DNN function, so we would pass something like this, this in string, right? So then it can be evaluated, and then that will evaluate that function and return a compiled model of that. So okay, so moving on to the training. So training, same exact thing. We're just going to go ahead and pass the config. So it's kind of easy actually, since we've adjusted a lot of our helper functions. Is get dataset now only takes config, and it'll read the config file. The model does the same, so we go ahead and just pass that. Call the same callbacks. This we need to adjust. And then to go ahead and run this from the command line, we're going to go ahead and add a command line runner. So we're going to go ahead and import argparse. I'll run you through how to do that quickly. So, okay, and then we're going to find two functions. So there we go. We're going to go ahead and return that. Okay, so I'm gonna go up here and I actually need to import JSON as well. So these are built-in libraries for Python. And then I'll go ahead and explain this. So basically we're going to create some sort of JSON file, and we're going to, in the JSON file, write down all these different parameters that we've established here. So we've got our epochs, we have our metric, our loss func, our model, learning rate, batch, dataset func, load func, right? So these are all the standard parameters we need for the base running, the running framework, right? When you get to the different models that require different sorts of inputs, the config will then you'll need to add into that those other inputs as well, right? So you're going to have to expand upon it, dependent upon, all of these subtle parameters you'll need to run your experiment. But that's the only thing you're going to have to really mess with. And we'll get to the data functions here in a minute. But so to kind of explain this, so when I go to run my model, I'm going to want to run it from the command line. I want to run my script. So I added this command using argparse. I used an argument parser to where I can say Python, my script name, and then pass some sort of argument on the command line. And what for this particular use case, that argument is going to be the path to the JSON file, where I have all my config parameters. And what this is going to do then is it's going to open that JSON file. It's going to load it into a Python dictionary, and then it's going to pass that dictionary to my run training function. So basically now the only thing I can keep this script the same. Only thing I need to do is change my JSON file. Or if I want to have a bunch of different JSON files, say I want to run different experiments, I can use the same script, but when I call Python, my script name, and then the config path or the JSON path, I'll just put in, the different experiment paths, right? And can easily adapt to the different experiments. So if you kind of remember going back to the beginning, I showed these, right? So these load func and these dataset func, and they have config and then train equals true, train equals false. Those are different than the original load functions, right? So if you go back to the original load functions and the original TensorFlow functions, they also have kind of those hand-coded parameters. So what we're going to do is I'm going to show you how to fix those as well. So here's load point. So all of your load functions, in order to fit into this framework, all need to follow this structure, right? They need to take these two things as input parameters, and you'll be able to plug them in and run them. So if these base functions don't work for you, you can go in your own script, just import from this script the running function, and then write your own load functions, your own dataset functions. As long as they follow the same type of structure, they'll plug in place and they'll work just the same. But just to show you, I'm going to go ahead and adjust these ones. So before we would just read a path. Now, if train is true, so if it's the training data set, we're going to go ahead and read the CSV for config train. So there's another parameter we're going to have to make sure we have in our config file is the train path to our train CSV. And then if not, well, then it's the validation. So the rest stays the same. So yeah, so then the rest basically stays the same. These are helper functions, so those are fine. When it comes down to the actual point data set, so we have this batch and epochs, we're gonna go ahead and change that to config and then train equals true. So in this particular instance, there isn't anything that happens when we have train because it doesn't necessarily matter for at least for this use case, but in future, right? And this is why I've built it in. When you start to deal with image tasks, right? So you're doing like image classification or object detection or semantic segmentation. One of the beauties of those types of workflows is you can use what's called data augmentation, where you can augment the images, and that's only done to the training data set. So that's why we need to differentiate between the two. So in this particular function, but that's for images, what we would do is we would say if it is the training data set, then pass the augmentation function on the samples. If not, if it's the validation, you want them to remain the same. So that's why we built it in here, even though we're not actually going to use it. And then the only difference here is then it's config epochs and then config batch. So there we go. And then for the get data set, we also need to change that as well. So, or no, we already did that. We already did that. That's just on the bottom. Okay, so that is it for the data. You've seen how we kind of have created this base structure that now all of our TensorFlow data sets are going to follow that kind of base structure, and all of our load functions are going to follow this structure. And then we're going to go ahead and move over to the models. So models, we want to go ahead and do the same thing. So here we kind of hand coded our layers. We're going to go ahead and create a new densely connected neural network, and we're going to pass the config. So one of the things that you do while you're doing hyperparameter tuning is, you, like I had spoken about before, is you adjust, maybe the number of layers you have, or the amount of neurons you have in each hidden layer, or maybe some of the activations and functions and stuff like that. So in order to facilitate that, and so you don't have to necessarily go through and recode everything, we're going to write this new functionality. So go ahead and start with a sequential model again. And then this time, so here's one of them configuration parameters, so layers. So for the DNN, if you're going to do a DNN experiment, you're going to need to make sure you have layers in your config file. But here we go. So for each layer, for each layer in config layers, which we will end up making into a list of integers, right? We're going to add a layer to our network with the same number of neurons as is the number in the list of layers. And then finally, we're going to add the final output layer. And return our model. So an example of this might be, let's say I want to have a list of neurons, and the first one I want to have 128, 128, 512, something along those lines, right? So now I can just pass that to my config file, and it'll build up that DNN for me. So then we're going to go ahead and move on to the convolutional neural network. So again, we're going to go ahead and pass config. So now different parameters that are going to be passed, again, based on the type of model you're using, and you'll just have to pay attention to when you are creating your configuration file. Go ahead and pass shape. So this, then we'll need a shape. So good example here would be what this would look like in a JSON file is, let's say I want 256 by 256 by 3. So 256 by 256 image chip, and it's a RGB image, so it's got 3 channels. That is what that would look like. And then we are going to go ahead, and this is a little different. And there's also tons of different ways you can do this. If you see different more convenient ways for you, you can kind of adjust. This is just kind of a general idea of how you might go about doing this. So here, another parameter we'll need is filters, and then batch norm, and then a list of dropouts. And this will be the first one. So the list might look like, since we have 4 convolutional blocks, the list might look like this, where you have 0, 0, 0.5, 0.5, whatever it may be. This will just allow you to easily adjust what the dropout layers are when you're doing your hyperparameter tuning. So then we're going to go ahead and just copy paste this here. And then And one last thing, we can then pass our number of classes, right? So again, not only is this nice for when we're doing hyperparameter tuning, but it's also, let's say I want to use the same convolutional neural network for different problems, right? And different problems have, different numbers of classes that I'm trying to predict. It's easy to just, now we can use this across, it's more general sense, more general realm, right? So, and then we're going to go ahead and not do the same for this subclass model because it's the same idea. You can go ahead and do that yourself if you would like. So now we're going to actually get into our config file. So basically, I'm going to copy and paste one here since I've already got it kind of coded up. This is for a densely connected neural network. So you'll have to go back through and make sure that any specific parameters for your model are added in, and then also any of the base ones from the trained data set, or also your loading functions, right? You got to go back through, make sure that they're all covered, especially if you go ahead and make your own functions and that plug into the training workflow, which I've done here. So we have our model. So we want our densely connected neural network. This is going to be evaluated, and we're going to have passed our config file. I want to use my load point function. I want to use the TensorFlow dataset point that I coded up. The path to my training examples is this CSV validation, and then the validation CSV for validation. These are the layers I want to pass for that model. I want a batch size of 16, 50. And then if I would want to add something like dropout in, right? If I want to go back and adjust this DNN to where I'm adding dropout on certain layers, I can go ahead and do that. I would just go ahead and plug in a new parameter in the config file and it'll allow me to iterate from there. So this is kind of the general workflow. Coming up, we're going to go ahead and go through running this system on some real world problems. We're going to I'm going to highlight how easy it is to transition using the same training functionality from doing some kind of regression problem where I'm using a densely connected neural network to some type of maybe image classification problem where I'm using a convolutional neural network, but the only thing I'm really changing is my config files, and a lot of the functionality, and at least the training functionality, is wrapped behind this framework, this kind of library, so that I don't necessarily have to mess with it every time, and I can kind of just forget about it. So hope you enjoyed, and I'll see you next time.